where I have the camera that I'm coming in later maybe. But first of all, for quick recapping, I think we have started the discussion about the pixel, right? On the last class.
Yes, sir.
Yes, sorry, we started the discussion about the
Yes, sir.
pixel.
Yes, sir.
Yes, okay.
Yes, sir.
But we have not identified the pixel address, right? We have
No,
not
sir.
done that. Okay. For the pixel, before that, just we discussed about something. This could be important, like image and object, how they are different, and from the perspective of forming different images, they are always two-dimensional, but image actually formed from the object, which is actually three-dimensional, and the images are getting changed for the same object according to the viewpoint. As you can see, the viewpoint, or we call it the perspective of the viewer, that where from you are actually looking at, the distance, the angle, all can form actually different images. And then we said about the importance of the light source, that also actually create the images from the first condition is actually it has to be reflected and come into your eye. That is actually the concern. And the reality is always actually the viewing perspective is important for the graphics as well, that what actually you see in the object, they did not have that much changes, but actually very few changes create actually the perspective of the viewer is quite different. So that's actually the reality in concern. That pixel, we know that this is actually the picture element, the smallest unit in the picture, and the two image that you can see, one is actually the digital image, that in the any digital screen display, where you can find like the subpixel level that you can see, red, green and blue, while in the right hand side, that is actually in the graph, especially the small boxes can create in the pixel level, and that we consider as the standard format for our identifying the pixel. So every pixel on the graph or the space or in the screen, they have a specific location, and for that location we need actually at first the resolution. That means actually the number of column and number of row, which will create actually that small boxes. As you can see there, that for the pixel on the space can be defined from the axis. We know that axes are two types, y-axis and x-axis, and that y-axis are actually the vertical line. As you can see, the vertical line for the y-axis, so that that is actually and x-axis are actually the horizontal axis on the top screen, and that is actually, sorry, the vertical line for the y-axis, and this is actually the x-axis, the horizontal one, and x-axis indicate how many of that column you have, and y-axis indicate how many of that rows you have. Origin is actually that x and y intersected point in here, in the leftmost corner. Unlike in the graph paper we have actually in the down there in the bottom, but here you can find actually on the top, and then the coordinates that to identify a particular pixel on the graph specify how far along the x-axis, and it is then how far along the y-axis. That is actually the coordinate. So that if I have a certain pixel, that how far it is from the x-axis, okay, and how far it is from the y-axis, it gives you the reverse value actually. So that is if it is how far it is from the y-axis, give you the x coordinates value, because that will be counted in here, and how far it is from the y-axis, it will give you the y coordinate value. Okay. So that's about the pixel, that on their coordination. Now we will try to find out the address of the pixel. So if we consider this is actually a VGA is 640 and 480. That means 640 is a column that we have, and 480 rows we have. Now that that may create like third 307,000 and 200 pixel, or 3 lakh 7,200 pixel in the screen. So that many pixels. So individually all that pixel has some specific address. Address means actually this is maybe first one, second one, third one, like this way up to the last one is actually 307,200 number that pixel is. And we can identify actually by using some formula of that any individual of this pixel. Now if we consider according to the coordinate value, that say like 00 coordinate value, what should be the pixel address? The one, number one. So that's why if it is 0 1 0 for this point, this is actually this pixel, which is actually 1. So if we have say like 2 and 3 the coordinate value, that means this is 1, this is 2, and actually 1 2 3. So this is maybe here, okay, 1 2 and 1 2 3. This is maybe here, this point coordinate, but you see the coordinate is actually a cross point, but a pixel is actually an individual object, a square box, right? So for this point or coordinate, the pixel is actually this one. We are going like this way, okay? So if we have a origin point in here, then our pixel should be in this way. That means if I say like 3 and 2, so 1 2 3 and 1 2, this is actually the coordinate value, right? But the pixel would be which one? This one, okay? The same way that if we identify, then actually the last point which we will give actually the coordinate value is 639 and 0, and here also 0479, because that 1 is less, as like for the indexing, as you can see that for 00 we are getting 1. So definitely for the last one to get in here, it should be actually 639 and 479, that one. And if we check like 640, that is actually this point, and this point is actually, you can say, this outside of the box the pixel address would be. So this is actually the condition, the formula for that whatever the pixel you need to consider for a coordinate value, that you need to find out that the I and j means x coordinate the highest value for your what is called that resolution, and y coordinate that highest value resolution, it has to be 1 less, okay? All right, we are coming in that point. We are going to solve one, then actually it will be more clear to you. So let us have the attendance. Let us finish it first, then actually we'll do it. Can you come to the video, please? All right, the marks that I have given to you for the first amount that day, that also slightly little bit changed. Few of the marks has been changed, okay? So next coming few days, so up to tomorrow I am actually very busy, so I will not get time. So after tomorrow, maybe during the Eid time, actually you will get your script in your email. Okay.
Sir, can I get my mark?
Alif Laila Jannat. Mohammad Ashikur Rahman Ashik. Mohammad Ashikur Rahman Ashik. Mohammad Alamin.
Yes, sir.
Are you there, Alamin? Yes. Okay, got
Yes,
it.
sir.
Nishat Ara. Nishat Ara. Nishat Ara, I can see you. You need to unmute. Are you there, Nishat?
Yes, sir.
Yes, got it. Shahidul Islam Antar.
Present, sir.
Okay, Antar. Sumaya Akhtar.
Present, sir.
Sumaya Arifa Ritu.
Present, sir.
Okay, Ritu. Jinatun Nisa.
Yes, sir.
Okay, Jinat. Parvez Alam.
Present, sir.
Okay, Parvez. Redwan Ratul.
Yes, sir.
Okay, Ratul. Salvi Saba.
Yes, sir.
Okay, Salvi. Zakaria Hassan Pappu.
Yes, sir.
Okay, Pappu. Maria Mehjabin.
Present, sir.
Okay, Maria. Israt Jarin.
Present, please, sir.
Okay, Israt. Abdul Khalek.
Yes, sir.
Okay, Khalek. Rabina Afrin Ami.
Yes, sir.
Okay, Ami. Tajnova Yasin Esha. Sorry, Tajnova Yasin Esha. She's absent. Shariar Toyan.
Present, sir.
Okay, Toyan. Hussein Ahmed Antar.
Present, sir.
Okay, Antar. Pratyasha Roy.
Yes, sir.
Okay, Pratyasha. Sharnika.
Achnova, yes, initial, sir. I couldn't hear you that day.
Yes, Esha, I cannot hear you.
Yes, sir.
I cannot hear you. Can you be a little bit loud?
Hello, sir.
Yes, I can hear.
Yes, sir.
All right. Sharnika.
Sir.
Okay. Khadija Ria.
Present, sir.
Are you there, Ria?
Yes, sir. Can't you
Okay, got it. Rahat Islam Rupu.
Present, please, sir.
Are you there, Rupu?
Yes, sir. Present, please.
Yes, I got it. Mahmoud Akhtar.
Yes, sir.
Okay, Mahmouda. Didar Al Mahmoud. Didar Al Mahmoud. Tamanna Tabassum.
Yes, sir.
Tamanna. Saif Mahmoud Sifat. Saif Mahmoud Sifat. Fairuz Tanji Machal.
Yes, sir.
Okay, Achal Sadiatun Nisa Shetuli.
Yes, sir.
Okay, Shetuli. Mustafa Iramudar.
Present, sir.
Okay, Uday. Sadia Hussain Mouri.
Yes, sir.
Okay, Mouri. Sadia Akhtar.
Yes, sir.
Sadia Mantakimo Rahman.
Yes, sir.
Okay, Atik Faisal Imon. Atik Faisal Imon. Rahul Devnath.
Yes,
I
sir.
can-
Yes, sir.
Yeah,
Yes, sir.
got it. Nishat Taslim Jyoti.
Yes, sir.
Okay, Jyoti. Sadat Mahmud Khan. Sadat Mahmud Khan. Firdaus Hassan Rifat.
Yes, sir.
Okay, Rifat. Khaja Minhas Monib.
Yes, sir.
Monib. Nahida Islam.
Yes, sir.
Okay, Nahida. Hasibul Hassan Shanto. Hasibul Hassan Shanto. Sharmin Sultana.
Yes, sir.
Are you there, Sharmin?
Yes, sir.
What about your video?
Oh, sir, sorry, sir, but sir, I have some problem.
Ryan Hussain.
I can.
Yes, sir.
Ryan. Muhammad Alamin.
Yes, sir.
Muhammad Alamin.
Yes, sir.
Alamin. Tariqul Islam.
Yes, sir.
Okay, Tariq and Ashikujaman.
Yes, sir.
Okay. Muhammad Alamin 3055. What about last class? Do you know your attendance? Some of you, I can see you are present today, but you get actually frequent absences. I think you need to be careful. I'm not sure about what actually your first term performance is.
স্যার এমনি হাসিবুল আছে শান্ত
Shanto, yes. What about you? You also absent on last class as well, Shanto?
স্যার ইলেকট্রিসিটি প্রবলেম এগুলো
Electricity problem. Okay, please do not try to manage. Okay, coming to the class is important now. You will feel it because next few classes you have no specific other document. You have to come in the classes actually, no slides about the algorithm that we are going to start.
The previous class, my PC was getting update and the Zoom app in my mobile, the Zoom app didn't turn on the microphone. Last night update it fixed.
You were present, but you had a problem in microphone. You said in last class. Alamin or
Sir, me, sir.
yes, you had a problem in microphone. You said, right?
Yes, sir. Previous day, the Zoom app didn't turn on the microphone, and my PC was getting update.
Okay. All right.
Previous night update it fixed.
Anyone missed in here today for attendance? Oh. Okay. All right. Let's move on. So you just remember me when we have 5 minutes left, so that maybe we can give you the marks of the remaining. So those of you have missed it. And also maybe we have, I said we have some update. Maybe those of you have got 50 marks or something, like around 50 plus. Those students' marks I try to update. So maybe we can update the marks by that time. All right, let's come to now pixel identification. As you can see the formula here, that any individual pixel that on the screen or space that we can identify for their address, as we have said, like any random pixel if they have the coordinate value. As you can see that for that address can be computed with the address of Pij, consider any coordinate value. The formula is at first we have to take the address of origin, that is 00, then plus the j into I max plus I. Now what is I and j? That the coordinate value that you have, and I max and j max are actually your that resolution which has been defined. So for finding address, as you know, for any image as well, whenever they have been defined, they are defined with the resolution that how many actually that pixel it can be, and according to that resolution in the frame buffer, that according to the address that we have the intensity value. As we know, this is actually the raster graphics that they have. Intensity value means actually the color value, as you can find out. So for Imax is the maximum number of pixels in the row, so that I on that value of x-axis actually that is the Imax. 640 is actually the Imax in this case, and j is actually number of rows that we have. Now condition of that I and j has to be that it can be 0 or greater than 0, but must has to be less than x max, that I max or j max. So this is the condition for the I and j coordinate value that you are actually considering at this moment. Okay, so there are some problem in there. Let us actually solve with maybe we go for let's say we consider a not that many pixel. It's really the first one got bad. Then you can tell me the resolution of that screen. So can you tell me the resolution of that screen?
6 into 10, sir. 6 and 10.
6 by
10.
10.
Yes, sir.
No, that is wrong.
So 10 into 6.
10 by 6.
10 by 6, right?
Sorry.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 10 by 6 is actually our VGA if we consider that especially that the resolution that we have 10 into 6, maybe 1, 2, 3, 4, 5, 6. So the coordinate points, as you can see, this is actually, if it is 0, 0, this is 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9, 0. So that this, for this pixel, this is actually the last coordinate 9, 0 that we consider in here, that 9, 0, as you can see, that one less. This would be actually 1, 2, 3, 4, 5, and 6. So that it would be
50.
0, 5. Right? We consider this way because this is actually 6, 0, or 0, 6, or this is maybe 10, 0, but those points, pixels are actually going outside, right? For that point is actually outside the screen. So that's why the condition we always have any p, that random p, which is having two coordinate values, say I and j, that that I and j must has to be greater than or less than that condition it need to fulfill, and this could be actually consider say 9 and 5 maybe last point. Now consider that we may have say that we may have given say p is having ij value. So what we can take, we must have to take any value in between this one, right? Then only we can find out the address of inside that screen. So consider we may have say 5 and 3. Now to find out pixel address of P. So if we want to find out the pixel address of P, what is the formula we know? The formula is actually for computing that P of I and j, okay, is equal to that. First actually you need the address of the origin, right? That origin is actually what? The 0, 0 coordinates. Then we need plus I into j max. So I and into j max. So I'm just writing down. It should be actually in small letter in subscript and plus I, isn't it? That was actually the formula. I into j max plus I. That was actually I or j. Uh, j into I max actually, not I into j.
Yes, sir.
What is my screen when I cannot see that? Yes. Got it. So it should be actually j into I max plus I. J into I max plus I. So that no, it should be, I don't know how we can overwrite. So address of origin plus j into I max and plus I. Okay, so according to that, the first thing is actually when we take that I and j value, which is actually 5 and 3, and we go for the address of the origin. As you know that address of the origin 0, 0 is actually 1, this one. So if 0, 0 is the coordinate value here, so the first pixel address is actually 1. Then we go for plus. Then what is the value for j?
3.
J is actually 3. 3 into, because the coordinate is actually 5, 3. J into I max. I max is actually
9.
10. I max is 10. The value for I max and J max is actually what your resolution that actually you have. So it is actually 10 and the J max is actually 6. Okay, so this is I max is 10 and plus I is actually 5, right? So if we do the calculation here, so that is actually the 1 plus you cannot do the addition because the multiplication we have to done first, 30 plus 5, and that is actually you get 36, right? The address we got is actually 36. So what we have actually followed here, that the value of I that can be actually greater than or equal to of 0, the value of I, or we can have the value of I is actually greater than or maybe we can write down in here, or maybe less than that I max, right? That is must we need to actually follow that we have said the value of I must be. So that's why our condition of that 5, if it is 5 is actually less than 10, so that's why this is actually valid. So if we have in your question like a pixel value which is to identify the address, say like if would have 10 3, say like the value of I is 10 in the question, then actually you would have find out some address which is actually outside in the screen, because 10 is actually not satisfying this condition. It is not less than Imax. Imax is 10, so it is not actually less than 10 is not less than 10, so it is actually equal, so it will not actually accept. So the end of the day, whatever you would have gone, actually you will find that this is actually outside that box. Now this is for the I, the same goes for actually the J, that you have to have the value of J has to be greater than or equal to 0, but it must has to be less than J max. That means actually 6, less than 6. Now let us find out that whatever the 36 that we have got, now you can check here that which one is 36. So 1 2 3 4 5 6 7 8 9 10, then this is 20. So after 10, 11 to 20, 21 to 30, then 31, 32, 33, 34, 36. So this is actually the pixel that we have got, this one, right? 1 2 3 4 5 6, this one, 36. So this is the pixel of that P53. Now if we identify, you can also find out with the coordinate value that 1 2 3 4 5 and 1 2 3. You see, this is actually the coordinate point, and for that coordinate point, this is actually the pixel address. Okay, so this is the way actually we can identify. Very simple. The only condition is whenever the VGA has been say like that 10 into 6, then in here the VGA is actually 10 into 6. That means actually that I max is 10, while the J max is actually 6. Okay, so on the basis of that, actually we can do. Now we said let's consider that we have maybe any value which is not actually valid. Validation, we can check if the Pij has been given. Maybe we just said the value which is equal to or maybe more than that, so like 11 and 4, so that we have actually the I value in here is 11 and 4. Then actually what will happen, if the P is given, P is say like 11 and 4, then we know that our address of 0 0 or the origin is 1, say consider 1 plus, then we go for J into Imax. So what is J here?
4.
J is 4, right? 4 into, then Imax is actually 10, right? And then we go for that what is called that plus I is actually that 11. Okay, now we got actually that 4 into 10 is actually 40, then 11 is actually 51 and 52. Now okay, now the address you have got is actually according to the valid resolution that you have. In between that you can find that address, because what is actually the pixel altogether that you can actually identify is actually 60, isn't it? But this will not be valid in that sense, because from the coordinate value if you go, you will find that this is actually going outside of that boundary. Like if we go for 11, then 1 2 3 4 5 6 7 8 9 10 11, somewhere that it should go, and 1 2 3 4 somewhere actually it should be according to that the number of column that we have. So at this moment you can actually define that 52 should be in somewhere in here, because the value of I that we got, so the value of I is actually that is greater than or equal to that condition they do satisfy is 0, but that is actually not actually the what is called
Less than of
that
max.
yeah, less than of that 10, that is I max that we have. So this is actually the problem. So according to that condition, you can say that this is actually not inside the screen, it will be outside the screen in somewhere, that may be in here, wherever actually you can get it. Okay, so if you have something like that which is actually not in there, so at the very beginning you check with your Imax and Jmax that whatever the I and J that the value you have, and then actually you can consider it, right? So very simple for the calculation. Actually you only need to know the formula, then actually you can do it, right? So do you think that you can do it, this one? How many minutes we have still? Just can you just quickly do this one for the first one that you can see, which is VGA mode is 15 into 12. That means 15 columns and 12 of the rows you have. Your pixel address has coordinate 86. Then determine the address of PIJ. And you can show the pixel on the position, like in the graph that we are drawing, you show in there actually. Can you do it now? Yes, are you doing it?
Sir, the address is maybe sir 99.
Have you done it? Can you show me?
Sir,
You can actually show it with your camera, that if you want to.
sir, not in the sir graph sir, just calculation sir.
Sorry?
Sir, just do the sir calculation.
Do it on the 15 and 12, then actually find out, because that is the way you need to do. As you can see, you have to put that in the formula, you get the value, just draw quickly with that 15 and 12, okay, and then actually show where actually your address is, that one, right, the way we have actually shown in here. So like this you need to actually draw quickly. That's why I put like 10, 12 maybe of those boxes, not actually a big resolution number, and from there that you can actually identify. Who can show actually that you have done?
Sir, result is 103, but I haven't done it on the paper.
Is it 103 you have got?
Yes, sir.
Someone said 99. So can you just show it? You can show it if you can take a picture also, you can show it. You can there are many ways that you can show. If you want to share with that one, or maybe through the camera also you can show it.
Sir, just I've done on calculator. Like the origin is 00, so it's 1.
Sir, for
plus
00 sir, this is 1 sir.
6 into
Yes,
15
always 1. You have seen
Then
that
sir,
first
6
one
into 15. Then
for
plus
origin.
8.
plus 12.
Last one, the value
So
of I.
J
The
into
value of
I
I
max,
is
so
8.
So 6 into
Oh, sorry, sir. I consider
6 into 15, right? Plus 8, so it should be 99, I believe, maybe.
Yes, sir.
Yes, sir, yes,
It's
sir.
99, sir.
That's right, sir.
It should be 99, I think. 6.
Sir, it's 99, sir.
Yes. So if we just draw that one, 15 of that column and 12 of that row, then you can find out that actually coordinate of 8 and 6, that is the pixel, and if you now then count, then you will find that should be the 99 number exactly on the graph actually, right?
Yes, sir.
Yes, okay. All right, I hope that now in some of the cases you have to actually also be active in the class. We will have some task basis as well. This is also part of the performance evaluation, okay? So you also have to participate, and also I want to see that you are active. That also give me a feeling that you are actually doing it. So there is an example as well. You can try. In some cases, in midterm, definitely you will may have a problem that you need to actually solve. Very simple problem. If you do it, you can actually get the full mark. All right. About the geometry, we are moving now for actually drawing some of the geometrical primitives, especially these two that we are actually going to do, that the line drawing and the circle drawing. Okay, there are some certain algorithm that we are going to check. For line drawing, we are going to check two algorithm, and for circle we are going to check actually one algorithm. For the line drawing, the first one we will check for DDA algorithm, it's called in short, which is a digital differential analyzer, and another algorithm for Bressenham's line drawing algorithm. And the second one for the circle, we are going to use actually a midpoint circle algorithm. There are certain that algorithm generation technique that huge mathematical going through. I will say that whatever we can do, we really can go for it, because for one algorithm generation we go for two classes, maybe not one class is possible. These are so big, but in your case, like, we will try to have the algorithm, the formal algorithm, we will try to learn from there, and then actually we'll try to apply it, so that also you'll find the programs in there, that for this algorithm how to write the programs, you can actually run it in your computer and you can find out. Okay, for DGA algorithm, for the very first, we need to actually go through some of the basic, as I will actually show you that if you okay, can you see,
Yes, sir. We can.
can you
Yes,
see
sir.
the screen that
Yes, sir.
Yes, sir. The paper.
right?
Yes, sir.
Okay, the paper that you can see, I hope that you can read as well. Not very good light I have in here now, but still I think that would be okay. If you, for any random space, okay, as we go for, I think we don't have that much time, so I'll be a little bit quick for pre-discussion. This is actually pre-discussion about the DD algorithm. So we call it actually the digital can you see the, I think, is it dark, is it readable?
Yes, sir.
This is
Okay.
okay.
Okay, that's fine. So digital differential analyzer, that is DDA in short. You can understand is the name suggests that maybe some difference between something that can maybe identify this algorithm DDA, very simple algorithm, especially for the line drawing algorithm. Okay, so some basic discussion that you have done in your actually SSC, HSC level that we have actually done this one about a point, about a line. We understand a line is actually formation of 2 points, right? Do you agree?
Yes, sir.
And if we consider that is in a space, then actually we can identify with that x and y coordinate. Already we know that this is the way we need to identify. How? Like this should be x1 and y1, the coordinate. This should be maybe x2 and y2 coordinate, right? As this is my x, this is my y, right? And we know that a line, always we can find out any line by only 2 points, and that 2 points are actually nothing but that of that, let me make it that 2 point, the end 2 point, end points we call it, like the end point, if we know, because line is actually infinite, isn't it, if we don't have that any end point. Now what is actually x1 y1? If we can find out, this is our origin 0 0 here. We are considering as a graph from that concern, and this is actually x1 as we know, right? And this is maybe the x2 on the x coordinate that we have. This is a y1, and this is maybe the y2. Just consider this one more. Now we know that difference we have said. What actually that is, we call actually a dx or del x, right? We know that this is actually what, how we can get x2 minus x1. This is the distance, right? We are talking about this distance. The same way y2 to y1, that is actually the distance, and can we find out the del y, which is actually del y or dy is nothing but y2 minus y1, right?
Yes, sir.
Understandably that my value of x2 y2 is actually more than the coordinate value of x1 or y1. That's why we have taken x2 minus x1. If we consider actually in the reverse one, that x1 minus x2, because we know that the x2 is actually greater than x1, that's why we have taken x2 minus x1. That is actually the distance or difference that we have. Now there are some certain line equation for the x and y, if you can remember that one was actually y equal to mx plus c, right? Very common equation, you can remember now maybe that we use. Another one we had, like if we have 2 points, then actually we can find out that y minus y1 is equal to y2 minus y1. You see that this, that del x and del y, that is x2 minus x1, and in here x minus x1. There is another equation that we had, right? These values are actually indicating that this is that x2 minus x1 is del x, y2 minus y1 is del y, right? And this x and y, the value
Standard x and y.
Okay, so that we can actually find out the equation for that x and y. Another one we have x by a plus y by b is equal to 1, right? Now we may focus actually main this one, that equation we are going to use. What is m here?
So the slope.
The slope, right? And slope is actually how we identify the slope. Slope is according to the base, and actually how much degree actually it has the relationship, so that if we consider to find out that which degree I'm talking about, so if we just join that one, then this is my del x, this is my del y, right? And this is actually my theta, that this is on that actually degree on that angle, that line has a slope. So we know that the slope can be defined as m is actually del y divided by del x. How we can get it? We get it from the tan theta, isn't it?
Yes, sir.
Tan theta, as we know. Tan theta, we know how it is. This is actually that perpendicular line divided by the base, right? In Bengali, we call it lombo by bhumi, as you know, that perpendicular that line. So that m equal to tan theta that we got. So up to at certain point, that the slope actually become 1, and then we can find out a different scenario for it. What actually I meant the different scenario, when say like that del y and del x is actually greater than 1, is greater than 1, that means that you will find the theta is actually greater than 45 degree we will get. So that the scenario of that line in any space, if we consider, maybe this line for this is say number 1 will be something, it should be like that. So this line, if we go for this way, so this is my 2 point, this theta is actually more than 45 degree. Tan theta tan 45 is 1, as you know. So a condition where actually del y and del x, if it is actually equal to 1, then actually theta is equal to 45 degree you will find. That means indicating that exactly maybe in the middle that we have say like this 45 degree. So the theta is actually 45 degree in exactly this one. So this is maybe number 2 that we are considering. Another scenario can be where actually the del y and del x should be less than 1, and if it is, then actually theta would be less than 45 degree. Like this number 3 can be like this, which is maybe we have drawn in there, like which is actually not less than actually 45 degree. So if we consider the line, then you see that this is actually 3 possible actually where the line can be, right? Either maybe less than 45 degree, either maybe equal to 45 degree, or maybe greater than 45 degree, right?
Yes, sir.
Yes?
Yes, sir.
Okay. All right. Then I think we need to stop. It's more than 9:30. This is, we have not started the algorithm yet, but this is actually some primary, you can say like a brushing up that we need to do, because whenever we go for algorithm now, we will use most of the time that differences or distances that we have calculated, that del x on del y, and on the basis of that we will try to find out the increment value. So end of the day, what this algorithm will give you, algorithm will start with this 2 of the point, then that every different point, because a line is consist of many number of points. So if we can find out the values of those points in between, starting from that point, and our algorithm will stop in the last point, so that in between all those points, if we can identify, then actually the line will be drawn. This is the logic, right? Did you get it?
Yes, sir.
Yes, sir.
Yes, that we will actually find out on the next day. So I hope that you will have a very good and safe Eid, and that is advanced Eid Mubarak to all of you.
Yes, sir. Eid Mubarak, sir.
And
Eid Mubarak,
I
sir.
hope, yes, you celebrate the good time for next 3 days. Or we are not going to have any class in this entire week, right? Maybe, right?
Yes, sir.
Yes,
Next
sir.
Sunday.
This is maybe
Sunday.
we had actually, yes, a long gap, I think. So I'll upload actually this one, and also I know that after actually when Thursday you will be free, so better started to revise that what actually we have and make a plan, because we might have exam maybe end of first week in August or in the second week somewhere. Maybe there is a date they have been announced. Okay, those of you have not got the marks, you just send me a message now in here in the chat box so that I'll